Welcome to our channel, Math Defined. In this video, we will explore what happens to exponents and powers when they are multiplied or divided. I have included several examples for both, and you can find sample problems for what you might need in the timestamps in the description below. As I said before, the focus in this video is on what happens to the exponents when they are multiplied or divided, not the value of the simplified power. Here we have the expression 4 squared times 4 cubed, or 4 to the third power. As with any expression, we need to follow the order of operations, so we will simplify the exponents first. And again, we are focusing on the exponents themselves, not the value of the power. So to simplify 4 squared, I will write it out in expanded form, which is 4 times 4. Then I will do the same for 4 cubed. The last step is to write this group of 4's as a single power. The base is 4 since it is the factor being repeatedly multiplied to itself, and the exponent is 5 since there are 5 4's, resulting in the simplified power 4 to the fifth. Seems pretty easy, but what if our expression is 3 to the 23rd times 3 to the 7th power? Would you want to write out 23 3's and then another 7 3's? Of course not. There must be a pattern that we can find to use as a shortcut, and there is. Let's look back at 4 squared times 4 cubed to see if we can spot that pattern. First, we see that both powers have the same base of 4. Then looking back at 4 to the fifth, we see that instead of counting the number of 4's we have written out in expanded form, we could just add the exponents, 2 plus 3 to get 4 to the fifth power. This pattern that we just found is called the product of powers rule, and it states that when multiplying powers with the same base, you keep the base and add their exponents. This rule will make simplifying 3 to the 23rd times 3 to the 7th much easier. Since the bases are the same, we will bring over the 3, then add their exponents, 23 plus 7, to get 3 to the 30th power. Here we have 5 squared raised to the 4th power. We essentially have a power being raised to a power. What do you think will happen with the exponents here? Since the parenthesis is between the 5 squared and the exponent of 4, everything inside the parentheses is the base. So let's write this out in expanded form. We have 5 squared multiplied to itself 4 times. Then we can simplify 5 squared by writing it out in expanded form. The last step is to write this product of 5's as a single power. Since the 5 is the factor being repeatedly multiplied to itself, it is the base. And we count the number of 5's we have here, which is 8, and that is the exponent, resulting in 5 to the 8th power. Do you see a pattern? If we keep the base of 5, then multiply the exponents 2 times 4, it will result in 5 to the 8th power. This pattern is called the power of a power rule, which states that when simplifying a power of a power, you keep the base and multiply the exponents. This time, we have an operation of multiplication inside the parentheses raised to the 5th power. An expression written like this is called a power of a product. Now, if the goal here were to find the value of this expression, we would follow order of operations by multiplying the factors inside the parentheses and then taking that product and raising it to the 5th power. But again, the focus in this video is on what happens to the exponents in this expression, not finding its simplified value. Since there is a parenthesis between the number 2 and the exponent 5, this means that everything inside the parentheses is the base. So there are 2 bases here inside the parentheses. To simplify the exponents in this expression, we need to use the power of a product rule, which tells us to distribute the exponent to each base inside the parentheses. Distributing the exponent to the first factor of 3 results in 3 to the 5th power. And then distributing the exponent to the factor of 2 results in 2 to the 5th power. And we can't forget to bring down the multiplication sign that is between them. Since the bases of these two powers are not the same, we can't simplify the exponents any further. Now let's practice what we just learned. I encourage you to try these on your own first and then come back to check your work. In problem number 1, we have two powers with the same base being multiplied. Do you remember the rule? When the bases are the same, we keep the base and add the exponents to get the simplified power of 8 to the 14th. Problem number 2 has a power raised to another power. Do you remember this rule? You keep the base and multiply the exponents to get 6 to the 12th power. In this third problem, you may not see the multiplication sign between the 2 and the x, but there is one. When a number is next to a variable like this, it means that the number, which is also called the coefficient, is being multiplied to the variable. So let's rewrite it in expanded form just for learning purposes here. Since we have multiplication inside the parentheses, and the parenthesis is between the variable x and the exponent of 3, we need to follow the power of a product rule. So we will need to distribute the exponent of 3 to each factor or base in the parentheses. So first, we'll distribute the exponent to this first factor of 2 to get 2 to the 3rd power. And then distributing the exponent to the variable x, we get x to the 3rd power. This time, we will simplify 2 to the 3rd to get 8. And then bringing down the x to the 3rd, we get the simplified product of 8x to the 3rd power. In problem number 4, we have a power being raised to another power, so we will follow the power of a power rule. Let's look inside the parentheses first to determine what the base of this power is. Since there is a parenthesis between the exponent of 2 and the number 3, everything inside the parentheses is the base. And since the negative sign to the left of the 3 is inside the parentheses, the base here is negative 3. Now to simplify the exponents, we need to multiply them, and 2 times 4 is 8, resulting in negative 3 to the 8th power. If you've been enjoying the content on our channel and want to show your support, there are several ways you can help us grow and keep creating awesome videos just for you. Your support fuels our passion for creating content, and we're incredibly grateful for each and every one of you. Together, let's continue to grow and build an amazing community. Thank you for being a part of our journey. Now let's see what happens to the exponents when they are divided. Here we have the fraction 2 to the 6th over 2 to the 4th power. Remember, a fraction bar is also a symbol for division. So these two powers are being divided. What do you think will happen to the exponents? The best way to see what happens to these exponents is to begin by writing out both the numerator and the denominator in expanded form. Starting with the numerator, 2 to the 6th written in expanded form is the base of 2 multiplied to itself 6 times. We will do the same for the denominator. 2 to the 4th is the base of 2 multiplied to itself 4 times. Now we can cancel out these 4 2's, and you see that there are 2 2's left in the numerator with seemingly nothing left in the denominator. But of course you know fractions need both a numerator and a denominator. So I'm going to place this 1 in the denominator because it doesn't change the value of 2 to the 4th, and it gives us a number in the denominator. Now we can write the 2's in the numerator as 2 squared, or 2 to the 2nd power, and bring over the 1. Then we can simplify this fraction to just 2 squared. Just like with multiplying powers, there must be a pattern for dividing with powers. Do you see it? Let's bring down this fraction again. The first thing to notice is that both powers here have the same base of 2. And when we wrote both the numerator and the denominator in expanded form above, we took away or canceled 4 of the 2's. When we take away values, we are in essence subtracting. So if we keep the base of 2 and then subtract the exponents, we get that same power of 2 squared like we did before. What a great shortcut! This pattern or shortcut is called the quotient of powers rule. It states that when dividing powers with the same base, you keep the base and subtract the powers. Looking at this fraction, I'm sure glad that I know the shortcut to simplifying it. Could you imagine writing out 17 sixes and then another 10 sixes? Wow, let the shortcut begin. The bases are the same, so I will keep the base of 6 and then subtract the exponents. 17 minus 10 is 7, resulting in 6 to the 7th power. Pretty easy. Now let's mix it up a bit and use negative bases. The bases here are -7 because in both the numerator and the denominator there is a parenthesis between the number 7 and the exponent. This means that everything inside the parentheses is the base. So using the shortcut or the quotient of powers rule, we will keep the base of -7, then subtract the exponents. 9 minus 3 is 6, resulting in the simplified power of -7 to the 6th. All right, this next fraction I'm going to show you is going to be tricky. Since the powers here have the same base, we will keep the base of 5. Then subtract the exponents, 3 minus 7. Yes, 3 minus 7, not 7 minus 3. When subtracting the exponents, the order cannot be changed. You always subtract starting with the numerator's exponent minus the denominator's exponent. Let me show you visually why by writing the numerator and the denominator in expanded form. In the numerator, we have 5 multiplied to itself 3 times, and in the denominator, we have 5 multiplied to itself 7 times. Now we can cancel out 3 of the 5's, and we are left with 4 5's in the denominator with seemingly nothing in the numerator. But we know how to fix that by adding a 1 in the numerator. Now we can bring the 1 in the numerator over and then write the remaining 4 5's as the power 5 to the 4th. And the simplified power is 1 over 5 to the 4th power. Let's go back above and continue with the shortcut. We kept the base of 5, and then subtracting 3 and 7 results in -4. However, this power right now is not in simplified form because we can't leave negative exponents. When you have a negative exponent, you need to rewrite it as a positive exponent by placing the power as the denominator of a fraction with a 1 as a numerator. So hopefully now you can see why you cannot change the order when subtracting the exponents. If you need some more help with negative exponents, I have a separate video focusing on that. And if you ever wondered why any number to the 0 power is always equal to 1, I have an answer for that one too. Let's practice combining both multiplying and dividing exponents in one expression. As always, I encourage you to complete these 2 problems on your own first and then come back to check your work. Starting with this first problem, we have a fraction with multiplication of powers with the same bases in the numerator and a power in the denominator. We are going to simplify this expression as a power, not find the power's value. Since the powers in the numerator have the same base, we can use the product of powers rule. We will keep the base of 7 and add their exponents. 5 plus 3 is 8, resulting in 7 to the 8th power in the numerator, and we'll just bring over the denominator of 7 squared. Since the fraction bar is also a symbol of division, we can use the quotient of powers rule next because the 2 powers here have the same base. We keep the base of 7 and subtract the powers, resulting in 7 to the 6th power. This second problem might look a little complicated, but you simplify the exponents the exact same way as you did in the first problem. Since we have negative signs, it's important to pay attention to the parenthesis between the number 4 and the exponent. This means that everything inside the parentheses is the base, so the bases here will all be negative 4. In both the numerator and the denominator, we can use the product of powers rule because we have powers with the same bases being multiplied. In the numerator, we'll keep the base of negative 4 and add the exponents 8 plus 3 to get negative 4 to the 11th power. In the denominator, we'll keep the base of negative 4 again and add the exponents 4 plus 2 to get negative 4 to the 6th power. Next, since the two powers have the same bases, we can use the quotient of powers rule. We'll keep the base of negative 4 and subtract the exponents. 11 minus 6 is 5, so the simplified power is negative 4 to the 5th. I know that working with exponents can be quite confusing at times. I hope this helped you out. And until next time, keep math awesome.